afternoon, ladies and gentlemen, and a particularly warm welcome to APS members who've come up from your conference in town to this afternoon's event on the presentation of climate crises in human history. We've actually called it a presentazione, in the sense of it's a celebration. It's a celebration of this book, which is the culmination, quite honestly, of a long-standing collaboration between this museum and Bruce Mainwaring, who's in the front here, who is one of the three editors. A celebration in the sense that Bruce has been a member of our board and a great proponent of this museum for 4 decades or more, and all that time has been very much interested in the contribution of science to archaeology, and in particular the impact of environmental change, or understanding environmental changes and climatic changes as far as they can be determined by archaeologists. So he's encouraged us in a great many ways over those 4 decades, including running a series of major lectures, forerunners of the so-called Great Riddles at the present time, that have looked at climate crises in the past. 3 years ago, though, with Bob Giegengack, who's going to speak in a moment, and Claudio Vita Finzi, who's in the front row here, fellow members of the APS, they put together this conference over 2 days, and then there was a big public presentation which was, of which the impresario was Brian Fagan, to 500 or 600 people to actually summarize publicly what had happened. Now, the book has now been published, and you can actually purchase it outside. It has, I think, a dozen chapters. I will just check. It has 11 chapters and a long introduction by 2 of the editors about the importance of this issue. So the presentazione this afternoon, in a week where we've lost Silvio Berlusconi, is a celebration, double celebration, because in Italy all things are good, really, and the loss of Silvio has to be an added element to the great qualities of the Bel Paese. Anyway, a presentazione is essentially a celebration, and so this celebration will begin with Bob Giegengack, Gieg as he's known, actually describing his thoughts as they put this book together in his inimitably colourful way. And then Graeme Barker, the Disney professor from Cambridge, will give a sort of critique, a personalised critique, followed by Joe Farrell, who's the professor of ancient history here, professor of classics rather, in this university, who will offer a second critique. And then I will get these gentlemen to join me on the stage, and I'll see if they may debate a little. I'm not sure how much they will about climate crises in history. And then I'm going to invite you, and I've planted 1 or 2 seeds already in the audience, so that we can finish with a reception. A presentazione always must finish with some white wine. We can finish with some white wine in Lower Egypt at the end of the afternoon. I'd like to just quote from Brian Fagan's review of the book in the Times Literary Supplement. Climate change, he says, has become a political battleground. Prophets of doom and global warming skeptics trumpet at one another like mammoths on a primordial steppe. We archaeologists are fortunately off stage, but the revolution in climatology and our increasingly fine-grained data raise an important question. What lessons about human responses to climate change can we learn from the past? We have here a tantalizing glimpse, he says, as a result of multidisciplinary research into ancient climate change that lies ahead. Future archaeologists and historians will be spending months in paleoclimate laboratories working alongside climatologists. The data we need demand nothing less. This book, he ends, reminds us that those who pontificate about climate change, present and future, will be well advised to look backwards. We have much to learn from our forebears. Well, I learned, I'm one of the contributors, one of the more modest contributors, I have to say, to this book. I learned a great deal from one of the editors, Professor Robert Giegengack, who's emeritus professor now, was in the Department of Earth and Environmental Sciences here in this university, having joined here back in the 1960s, I think, 1968. He's trained at Yale. He went on to do an MS at the University of Colorado in geology, and he got his PhD at Yale University in 1968. He worked on archaeological excavations with Yale as a geologist in Nubia during the 1960s, but he's well known to all, I suspect, here as someone who is wonderfully vivacious when it comes to talking about climatic issues, the past, and the world at large. So I'm going to begin by calling on Guy to start this afternoon's proceedings.
Brian Fagan didn't offer us any reason why he declined to contribute to the volume, did he? The theme of the volume we're talking about today is not new. I mean, Claudio and I first corresponded in the early 1960s when I was on my way to Egypt to do a stratigraphic reconstruction of the recent geologic history in the Aswan Reservoir as it was becoming Lake Nasser. And Claudio was doing a similar kind of study on the other side of the Mediterranean. I met Claudio in 1982 at a celebration of the retirement of Rhodes Fairbridge. And unlike most of those circumstances, when you meet somebody you've been corresponding with for a long time, Claudio in person was exactly as I had imagined. And then I didn't see him again until 2007 in Richard's office when we put this particular program together. But Bruce I've known for a long time. I met Bruce shortly after I came to Penn in 1960. I think our first meeting, in fact, was at a reception in honor of Emanuel Velikovsky after he'd given a talk at the University Museum. Is that right, Bruce?
Close.
I think so, yeah. And on that occasion, he suggested that the Egyptian pyramids were constructed not as tombs, not as monuments, but as fallout shelters. Now, this is not the first volume that has been published on the question of what can we learn from archaeology and late geology about the history of climate. And one of the most important books I ever read was Hubert Lamb's 1995 work, Climate History in the Modern World. But there have been many others. Most of you know Rat's Lice in History, Frederick Cartwright's book, Disease in History, the wonderful 2005 contribution by Bill Ruderman, one of those who was unable to participate in our project. His book is called Plows, Plagues, and Petroleum. I hope some of you have seen that. And the many books by Jared Diamond and Brian Fagan's contributions to our understanding of the Little Ice Age. The list goes on. There's so many of these books, you might well ask, why bother? And of course, that's the question I ask myself many times in the course of putting these manuscripts together as a book. But the process, Bruce and Claudio cooked up this idea. I think they cooked this up in UK, right? They recruited Richard Hodges and me. We invited participants. We didn't get everybody whom we wanted. We hosted the meeting in November 2008. Some of you attended that. Claudio found a publisher, the American Philosophical Society. We read, reviewed, and edited the volume with the inspired guidance of Mary McDonald, who's here. Stand up, Mary. Without Mary, we would not have been able to do this. Now, the process involves some selection on our part and some reaction to random patterns of availability. And of course, the result is not exactly as we envisioned it, because you cannot recruit people of this stature and subtly suggest to them what they might decide to say. But we're pleased with the outcome. And we're especially pleased because the collection includes 3 or 4 articles which are especially deep and comprehensive about an interesting, important subject, and probably would not have passed muster with conventional journals because the articles were just too long. So there are some important contributions in this volume that I'm pleased to say are there. Now we have our individual perspectives. Bruce is very interested in the environmental influences on human history. Claudio and I were interested in the effects on human history of patterns in the geologic past that are subject to rigorous reconstruction. So to illustrate the range of this temporal perspective, I'm going to offer you an outrageous metaphor. I offer you conventional roll of toilet tissue. 1,000 sheets, 4.5 inches by 4.5 inches, right? So the full length of this roll, 4,500 inches. We know the Earth is 4.5 billion years old, so each inch of toilet paper represents 1 million years of Earth history. It's a metaphor we can relate to. Now, I'm not going to unroll it because it makes a mess, but you can imagine. So here's 1,000 sheets, direct evidence of life in the form of modification of carbon isotopes first appeared about 180 sheets after the beginning. Fossil remains of plants and animals, which we can study, the hard parts of plants and animals, are very recent developments. They're only 145 sheets ago out of these 1,000 sheets. Animals first emerged from the ocean to colonize the land masses about 70 of these sheets ago. Dinosaurs came to dominate terrestrial environments 40 sheets ago, and they went extinct abruptly 15 years ago, and their demise enabled the diversification of the mammals who were already around into the various niches that were vacated by the dinosaurs. And these mammals included the first of the primates. Now, barely 7 sheets ago, the continent we now call the Antarctic drifted over the South Pole. And that impeded the transfer of energy from the equator to the poles, and the Earth began slowly to cool. As the Antarctic continent moved farther over the pole, interannual ice or permanent snow appeared on the Antarctic continent. This built to greater and greater thicknesses. This snow not only reflected back into space incoming solar radiation, but eventually led to expansion of glacier ice, which increased the size of the area of reflective surface, and the Earth became still cooler. Eventually, extraction of water from the ocean to support the Antarctic ice sheet lowered sea level so much that the Arctic Ocean became effectively isolated from equatorial circulation. And of course, the Arctic Ocean receives big floods of fresh water. The Arctic Ocean froze over, increased the Earth's reflectivity, and glacier ice began to accumulate around the land masses around the Arctic Ocean, and the Earth was plunged into an ice age. This is only in the last 7 sheets. Now, while this was happening, the lower temperatures favored photosynthesis drawing down the CO2 concentration in the atmosphere over respiration and decay, sending CO2 back into the atmosphere. So during these 7 sheets, the concentration of CO2 in the atmosphere fell. So much so that the biosphere, land plants, developed an alternative mechanism of photosynthesis, so-called C4 photosynthesis, to extract this reduced amount of CO2 from the atmosphere. It's widely acknowledged by botanists to be an adaptive response to vanishingly small concentrations of atmospheric CO2. So in the last million years, during this period of time when glaciers advanced and retreated because the effectiveness of transfer of heat from the equator to the poles was reduced, we have seen in the last million years both the lowest temperatures of the past 600 million years and the lowest concentrations of CO2. Now, in the last sheet, this is single ply. In the last sheet, the group of primates that we fondly refer to as hominins. We used to call them hominids, but now they're hominins. These are animals very much like ourselves that walk around a lot of the time on their hind legs, right? This frees up their front limbs to manipulate the environment in which they lived, right? They acquired big brains, language, culture, art, economics, politics, universities, museums, right? And very late in this history, the number of different hominins was reduced to only a single species, our own species. But just about 10,000 years ago, they learned to write down the things that they knew, and they no longer had to preserve this information inside their brains. So that is about the last 1/10 of an inch of this last sheet. I'll put it on edge. That's recorded human history. Right? Now, no, that's the 100,000 years of Homo sapiens. Recorded human history is the last 10,000 years. 10,000 years of recorded human history, and of the 5,000 teaching and research faculty at the University of Pennsylvania, it's been brought home to me repeatedly, of these 5,000 people, 4,950 of them study the things that happened in those 10,000 years. There's about 50 of us who worry about Now, the first thermometer was invented about 1690, but it wasn't widely distributed around the world until about a century later. So we have systematic, detailed climate data for the last 200 years. A period of time in which the growing human population actually visited enormous effects on the natural environment by our population growth, by our extraction of natural resources, by our disposal of the waste products of that activity at rates beyond the capacity of natural systems to assimilate. So a lot of things have happened in these 200 years. And we now are faced with the activity of a community of climatologists who are taking this record of 200 years, subjecting it to very, very detailed analysis, and projecting into the future computer models of what the climate will be like in the future based on this tiny record. And those of us who have some experience looking at the longer-term history of climate would like to think that that speculation might benefit quite substantially from learning all that we can about the information included in the previous 999 sheets. So, I didn't come here prepared to go through any of the data in the book or talk to you about that. Some of that data might emerge in our conversation, but I just wanted to let you know that we talked in the book about a small slice of this much, much longer record of climate change. And I think even that small slice has a lot to tell us, not only about the processes that affect climate change, but the likely consequences of those changes projected into the future. And that's all I'm going to say now, Richard. It's all yours.
He's left a wealth of instruments up here. Most people come to this podium with a PowerPoint, but anyway, here we are with all sorts of other things. Well, thank you, Guy. Fantastic. Well, I'm going to ask now Professor Graeme Barker to give the two critiques, so to speak, of this presentation. Graeme, I should convey two things. First of all, I came to this museum, first of all, with Graeme for the first time in 1980. We were colleagues at that time in the University of Sheffield, and worked with Graeme in the 1970s on field surveys in Italy. And at that time, I learned a great deal about his examiner of his PhD, who was none other than Claudio Vita Finzi, who's in the front row. And you will see the impact of Claudio's tutelage, if I may put it that way, on Graeme's subsequent career. He was subsequently director of the British School at Rome, so he knows a thing or two about presentazione, as well as white wine. And he went on to Leicester University before he became the Disney professor at the University of Cambridge and the director of the MacDonald Institute. He'll tell you about Disney and MacDonald maybe in a moment. But the long and the short of it is, over that long career, he's done a great many projects, mostly of a landscape nature in Italy and other parts of the Mediterranean, in particular in Libya and Jordan. And at the same time, he's been working on a number of much earlier sites, cave sites, both in Libya and in Southeast Asia and Borneo, where that element of the climate and environment and man's role in it has always been a theme that he's brought to the fore. So with that, I'm going to ask Graeme to take over the podium. I'll passo la parola.
Any of that. I should have briefly, but I won't explain that at the time, but it isn't that Disney, it isn't that done. The only teaching aid before I did the PowerPoint, yes, use the As I was leaving Cambridge on Thursday morning, I saw the Cambridge Evening News, drought fearing driest year for a century. My first teaching aid. So my reflections, I'm really just going to talk about how somebody like me as an archaeologist has been engaged in these sorts of questions. In many ways, it's in the sense it's to emphasise, I suppose, that the past, and I suppose I believe passionately the past, the human past, you know, we have got a huge amount to contribute to understanding the present and the future. But in many ways, we suffer from the fact that sort of everybody knows what archaeology is. They see it every night on television. And in Britain, there's a TV programme called Time Team, where there's a whole group of archaeologists, a sort of really eccentric sort of persona that's built up by television, not really very eccentric at all, but they're all sort of bizarre characters as presented. They go and sort an archaeological problem out over a weekend, and it's incredibly popular with 10, 11, 12-year-olds. And it shows that archaeology is enormous fun, which it is. It shows that archaeology is a team subject par excellence, very, very different from how scientists think of a team subject, meaning groups with PIs and postdocs and PhDs. In the projects I'm in, there are, say, 30 academics from different departments working together in the same cave or the same project. It's a very different model, actually, of teamwork. And it also shows that archaeology often involves a lot of clever science. But the one thing it never shows is that archaeology matters, and it's something, say, we labour under. And in a way, people always want simple stories. It's the simple stories of the past that always hit the headlines, that nature love, and television series and the press. But the past is full of complicated people like you and me. And so I say it's the starting point in many ways. And the sad thing is, in Britain, those 10, 11, 12-year-olds, it never translates into people really who want to come to university to do archaeology. Because in a sense, if you're a parent about to pay fees, it makes archaeology look either a wacky subject for serious people or a serious subject for wacky people. Anyway, just reflecting on the book though, so the first chapter, this is just taken, and I'm then going to move off from the book, but there's an splendid first chapter called Climate Change, Past, Present, Future by Claudio. And they started saying, we know the climate of the Earth is changing, we know it's always changed, and they show that it's always been unstable. There are these big changes at 100,000 years and so on through the Pleistocene, the Ice Ages. Then you've got further variations from the sunspots, and then they add on this impact of fossil fuel burning of the last 200 years, and then the enhanced greenhouse effect over the last 50. And where they conclude in the chapter is they basically say, well, what do we do about that in terms of the present and the future? And they say we can try to mitigate what's happening in terms of climate changes. We can try to prepare human society, if we can, for dealing with those changes. And then we can use, as indeed you just quoted, that's a quote from the first chapter, useful corrective to computer models of future climate based on short-term climatic projections. They're not that bit, but a little bit of that. And then they say, of course, the whole point of the book is, okay, can we learn from the past? Can we learn from past people-climate interactions? Can we learn from the successes and the failures? And I suppose I said, really I would say, yes, we can, and it's not easy. And that's why I started there. There are no simple stories. The chapters in the book by Claudio and others, clearly they describe, like the Sturt Manning chapter on radiocarbon dating, they describe how, of course, climate science is advancing and changing. There isn't such a thing as a fixed climate science. One of the really difficult aspects that comes across in most of the chapters, it's incredibly rare that you get good climatic data and good human cultural data at a scale and geographically close, so you can actually compare the two. And chapter after chapter, and the second thing is often you do get these continuous proxy records like deep sea cores or cores in, say, the Greenland ice caps. And then you get these discontinuous, complicated human records, and it's incredibly difficult to put those together. And time again, you've got somebody talking in the chapters where they're trying to talk about, well, how did climate change affect human life in Mesopotamia or wherever? And actually what they've got is there's a cave in Israel, Sorek Cave, which has got some stalagmite records that are used all the time. Great record from a cave by the Dead Sea. We are trying to link that to places further and further apart, the Greenland ice sheet, and so on and so forth. So one of the real problems always is it's incredibly rare to get high quality records which you can really put together. There are all the complexities of archaeological dating, and so again, you'll see in the chapters, often somebody's saying, well, kind of archaeologically, you can date this thing to 300 years, say, and then there's an event. And we suffer from that too, in people trying to say kind of sort of the specific historical event and trying to recognize that in an archaeological event, which is actually dated in a very different kind of way. So demonstrating correlations is incredibly difficult. Demonstrating causation is incredibly difficult. And this is one thing I've often shown my students. It's just a picture taken of, from a Greek student. She was looking at the kind of things that Claudio did, looking at stream valley changes. And this was two streams 5 kilometers apart in Greece. And what she has there, these are two streams, and what those boxes are, it says down the bottom, the length of each rectangle indicates not the duration of the alluviation, but the uncertainty of dating. Solid dashed and missing borders of rectangles indicate termini of increasing uncertainty. So in other words, this is kind of how you can try and date things from the radiocarbon dates. And so that's in the same kind of data from two valleys, which are 5 kilometers away. You then start trying to put that into the human data and different kinds of dating. It's just very, very difficult, very complicated. And so one of the key things for us also is, and I suppose, say, reflecting on this book, and I was thinking about my own projects, and I realised actually in many ways I'm going to go back through my major field projects, but I gave a seminar yesterday to students where I went from the back and moved up to where I am recently. I could start and move backwards. One of the things we think we really have to try to do is to get really high quality climatic and environmental records and high quality human records in ways that we can actually confront the two sets of data together, i.e. at the same site or in the same landscape. That's the first message. And so I'm running a project at the moment. It may be slightly sooner to get back into it following the arrest of Saif al-Islam today. It's a project in Libya, where we haven't been. We normally go to Easter, we haven't been this Easter. And one of the chapters here by Jennifer Smith is all about this question of it's Pleistocene climate change, human occupation in North Africa. She's talking about the East. But the general model at the moment is modern humans, our species, may have got into North Africa at a time when it was wetter, 30,000 years ago, crossing over. You see at the top left, there were lakes and rivers across the Sahara. We've been working in a cave that was dug by Cambridge archaeologists in the 50s called the Half Tear, a huge cave on the coast of northeast Libya, east of Benghazi. That's the 50s excavation over there. So we've been re-excavating it and trying to get a really good sequence of climate, environment, and what people are doing. So you've got taking pollen from it. The woman in the top, she's taking small micromorphology samples to look at tiny details of the sediments. Radiocarbon dating, an Australian team down there doing a dating method of sediments, OSL dating. The woman in the middle at the bottom is looking at tephra, volcanic dust, to date the sites. And there's another dating method of stalagmite and so on down at the bottom. And then a whole series of other datings. A PhD student at Cambridge is looking at the teeth of the main game hunted by the people, Barbary sheep, to get isotope records of specific climates, including the seasonality, what it was actually like to experience what the climate was like at a human scale. And that's clearly critical to move beyond, well, Greenland ice sheets say this, I wonder what it was like for these people at this tell in Syria, try and get it together. That's one. Another project looking at isotopes from land and sea shells, tiny micron, little animals scuttling around. They're all PhDs being done. All the soil that we dig is washed, and the plants coming up both in terms of activities, for example, strategies of humans that live in the very cold periods, storing plants, but also indicators of climate and environment. And this is kind of tiny, small-scale detail. This is just one piece of, it's a micromorphological slide through a piece of sediment in that 15 meters of earth that we dug. The thing goes down to, we got to 100,000 years, it probably goes to 150 to 200,000 years. And you can see here, in that, this is a micro slide, you can see there, period of inwash, sedimentary hiatus, gradual pulsing, shifting regime, standing water to inwash, fragments of dung, fragments of flint and so on. So that's the kind of thing we're trying to do to bring together human stories, environmental stories. We're doing similar work out in the landscape to get similar terrestrial records. So a deep core on the left, pollen from lagoons, similar stories from the coastal sediments that Claudio himself studied for his PhD in the 60s, tree ring data from recent trees, geomorphological data, and trying to map the archaeological survey data out in the desert from the mountains to the sea. And that shows the location of the site. But one of the things that's emerging, for example, at what's called the Younger Dryas, which is talked about in some of the chapters, a very, very cold episode before we get into the modern climatic era, and also the coldest phase, the last glacial maximum 20,000 years ago. It's now pretty clear that how that, although we understand in that particular period that there was this very cold last glacial maximum, how it actually played out in that Jebel Akhdar mountain and to the west of Morocco and in Sicily, Greece, the Balkans, it's gradually becoming clear it was experienced by people in different ways. So we can't just make easy assumptions about what the climate at a human scale, how it was that they experienced it. Coming back more recent in time, one of the chapters, chapter 11 by Marion Mulmeen and Charles Heim, talks about the colonisation processes of modern humans and then the changes at the end of the Pleistocene in Southeast Asia, which is another project that I've been running, that we're involved in publishing. In this instance, some amazing caves called the Near Caves. Again, were dug in the 1950s, and they found a modern human fossil. That's the skull on the left there, which we've dated to about 37,000 years ago. But modern humans were in this cave from 50,000 years ago. And you can see just what the landscape was like 20,000 years ago. Because of lower sea level, you can see how New Guinea connected to Australia, Borneo, where the cave is connected to an area the size of Western Europe was exposed by sea level drop. So in this totally different landscape, we've been re-looking at the cave. Again, this is the range of techniques we're involved with. The cave was visited occasionally by people who must have spent most of their lives in the rainforest. They're just dropping into the cave for a few days, a few weeks to hunt, and also to collect plants. On the tools, the stone tools, 50,000-year-old tools, we've got residues of the foods. So there's starch, sago starch, and sago is the primary plant that the modern Penan hunter-gatherers used to stay alive in the rainforest. Yams and tubers they were collecting. A lot of these things are highly toxic. One of the techniques Aboriginals use in Australia to deal with these highly toxic plants is they bury them in pits for several weeks in ash, and we've got similar pits. That section in the middle is intercutting pits at 40,000, 45,000. So modern humans were getting into the rainforest and learning different ways to live in them. Down the bottom, every time we've got people occupying the cave, We've got little peaks, and it's just the pollen, which is a kind of pollen that you get when you burn the forest. So the modern humans, as they get into the forest, they're burning the edges. So one of the headline projects that's come out from this, in a sense, is rainforest is as much a human artifact, or it's been shaped by humans for 50,000 years here. And the American rainforests are the same. As soon as people got into them, they're impacting on them. A wide range of hunting of animals at different parts, using technology to get animals on the ground and way up in the trees. But again, it's proving incredibly difficult. That on the left there is a pollen sequence from the pollen in the caves of a colleague. And we've got changing episodes. We know it was much drier, more seasonal there. But we're building very different seasonal specific models, because before we went there were simply a few pollen good sequences of what the environment was like from different parts of Southeast Asia, but not at this scale, which what it was actually like for the people hunting from this cave. So that's what we're trying to do, is to put the immediate landscape and the immediate climate around that cave, the 10, 20 kilometers that people lived in, and try to understand how they were operating. And then from the Holocene, 10,000, 11,000 years ago, the modern climate, we've got also deep pollen records of some caves, a long continuous record of human occupation. But one of the interesting things there is we've got rice phytoliths, little bits of starch of rice, little bits of silica of rice turning up there several thousand years before a current model of agriculture would change. And the Mainwaring paper talk about how at the end of the Holocene, this area the size of Western Europe was flooded. So clearly enormous movements of population that they talk about, and that's their model of when these main spikes of human migration in response to this extraordinary environmental change was taking place 50-odd thousand years ago, which is when they first appear in Near Cave. And then at the end of the Pleistocene, the Holocene boundary at 8,000, and it's probably in that context that rice and other things are moving around the landscape and turning up as they are. The Near East, there's a very fine chapter by Michael Dante, chapter 8, where he talks about the Mesopotamian and the Assyrian civilization and so on. So very briefly about that. This is a simplified chart of climate change. At the end of the Pleistocene, that's the late glacier, you see there was an enormously rapid spike, and it got warmer. And then gradually it went back to being very cold, the so-called Younger Dryas, and then another sudden spike again getting dry. This is an old and out-of-date chart. The important thing is, even with these old periods, we're often beginning to see there's climate change at a scale of rapidity that if kind of I hadn't experienced it, then at least my grandfather would have done, and we'd have had that close within a couple of generations, dramatic changes. But to give an example of how those changes were, in that warmer period, we know that woodland and grasses expanded right out over the steppes of Syria, and a site like Abu Huraira was used intensively for people who were gathering wild cereals. And then when we get into the Younger Dryas, the woodland and steppes retreated dramatically. Abu Huraira was abandoned. But the important point, in many ways, is that people responded differently. I suppose that's the other thing as an archaeologist, that we do have the capacity to respond differently. We can take wise decisions, stupid decisions, and so on and so forth. So in this instance, as it got much drier in the Younger Dryas, the Abu Huraira site was abandoned because all this woodland and steppe retreated. Down in the Negev desert, people responded in a different way. And in parts of the Levant, people started doing things with these wild cereals they were collecting that actually presaged agriculture. So people responded to climatic crisis in a different way, and that's just the key point I was making. In this, I've had a project before the current work in a wadi south of the Dead Sea called Wadi Fanan in Jordan, big study of archaeology and desertification. And in this particular wadi, when you move into the modern climatic era of the Holocene, 10, 11,000 years ago, it was significantly wetter in southern Levant. And so there was rain-fed agriculture. So that dry landscape down there was an all-year-round stream flowing down there, and the people were camped by the side of this stream as early farmers. And then it really did get true aridity, leading up to the modern sort of aridity today, around about 5,500 years ago. And there are some abrupt spikes as well. And what one sees is responses. Floodwater farming, like the wall down below, people began to develop techniques for dealing with this more arid climate. Also, we see the beginnings of specialised pastoral sites, which is the thing down there, new techniques for conserving and holding water. But the whole thing also was held together in this instance by a new sort of social structure, hierarchies, which again is also, I suppose, the fact of the social factor that we have to build into how people respond. And then finally, well, the second last is that the desert in the Roman Empire, two examples I've been involved with, I realised I shrank the map and the red dots got left out there without moving the map. But Wadi Fanam, that should be down here. And another area of work is that part of Libya. And in the Roman Empire, just to, again, it emphasises sort of difference and rather similar things, rather similar desert areas. I ran a project for UNESCO where Gaddafi years ago wanted to know how the desert edge had been farmed in the Roman period, and we found all sorts of evidence for how an indigenous, pastoral, small-scale farming society cashed in on the opportunities of empire, started growing olives and vines and producing olives in those presses to exchange with the cities. They developed systems of floodwater farming, the ones I've talked about, but also, and they reverted back to pastoralism quite after a few centuries, but we can also see that they could actually observe changes to the environment, deleterious changes. So some of their water control systems, they were deliberately blocking to try to control water. So we've got an example in that instance of a system where people were trying to do things to keep it sustainable. And the other area, that Wadi Fanam where we've worked, it was very important for mining. It was a main centre for copper and lead, very important for the beginnings of copper, actually. Copper exploitation anywhere in the world is as early here. But in the Roman period, it was the centre for Roman mining. Slaves were sent there, Christian slaves were sent there, organised by that big site, which is known as the town is recognised from documents. You can see these enormous amounts of pollution from the copper smelting. Slaves were sent there. A huge agricultural estate of fields was there to feed the workers, which you can see down below. And in this instance, it was completely, the landscape was totally devastated by this Roman imperial top-down organisation. Every tree was stripped from the landscape. The timbers for the pit props had to be brought in from outside. And from the geochemistry that we've done, it's clear that the landscape is completely polluted. So here, what you have is the sediments at the Roman, that curve at Fanam site. This is copper, zinc, and other horrible things. And this is the level of pollution down in the Roman period. This is today. The current safe level is somewhere down here. And these are bodies from the mining population. And you can see there that the norm for copper in your body is 10.5. There's a body there with 106 in it. Cadmium, the norm is 0.85. Somebody's got 4.3. So in other words, these people were completely polluted by the mining in the landscape. Lead there, the norm 4.1. Somebody's got 140.2 in their bodies. And these include also children and child workers. And the landscape is devastated today, so that they're brownfield sites, so that the Bedouin today are taking these pollutants up into their bodies from this Roman landscape. It's getting into the crops, the milk, the bread. And finally, the first project I ran actually brings me back to Claudio's work. There's a chapter by Claudio on river alluvial history around the Mediterranean. I ran a project where Richard and I worked together in a study of one valley, the Biferno Valley in southern Italy. And we ended up with this long sequence of cultural change on the one hand, from very early prehistory down through, you can see it right up to the present day, and different kinds of impacts in terms of erosion on the rivers. And what we found, that a lot of small scale, but there were two periods of massive impact of human activity. One of them was the centuries of the pre-Roman and Roman period, and the other is the last 30 to 40 years of industrial agriculture. And so what we found is in the Roman period, with that sort of technology on the right, there was it when climate change and land use in certain areas of that collided to create a kind of perfect storm over several centuries. There was absolutely massive erosion. But in terms of our own technological capacity, we've actually achieved what the Roman managed to achieve in the sense of damage to the landscape over 3 or 4 centuries. We've actually done in the last 30 years of EU subsidies, monoculture, agricultural technologies, and that's the same story that you'd find right around the Mediterranean. So they were the things I really took from the book as a whole. It is complicated. We have to try to get cultural and environmental climatic records in ways that we can really compare them. We have also to realise that we have to get them at these local scales, because actually how they played out for people was very different. People clearly had the same ability as us to do wise things, foolish things, without knowing what's going to happen in the future. And occasionally things did collide in ways where in a sense, it does all go wrong. In the sense, that's the issue, obviously, are we in such a situation today? Thank you.
Thank you, Graeme. A real romp around the globe as the book romps around the globe. Well, I'm going to now ask our second critical intervention from Professor Joseph Farrell. Joe studied at Bowdoin College and at Chapel Hill, and he's been a professor here at Penn since 1984. He's best known for his work on Virgil. He published a book, Virgil's Georgics and the Traditions of the Ancient Epics, with Oxford University Press in 1991, and a book on Latin language and Latin culture from ancient to modern times 10 years later, 10 years ago, with CUP, Cambridge University Press. And he's currently working on Juno's Aeneid. But to be honest with you, I called on Joe because of all the people who use this museum, he is the only one who teaches with objects from the Oceania collection. He, in other words, is someone who really does think outside the box as a professor. And I was just fascinated to think how someone who works on Virgil would approach this book with his particular interests in archaeology from the Roman world, thinking about it in a very, I suspect, Joe Farrell way. So I'm going to ask Joe if he'll take the podium.
Thank you very much, Richard. It's good to know that you did have a reason for asking me. I was curious about that, but I'm very appreciative of the invitation. Before I do get started, it's clear that I am approaching this from an outsider's perspective in many ways, not the perspective of an archaeologist or a geologist or a climatologist, but in fact, as a classicist and someone who's interested in classics and in ancient history. I will ask also the indulgence of the editors of this extremely interesting book if what I offer is not so much a critique of the book itself. In fact, as you'll see, I'm going to spend a certain amount of time talking about a different book, which I hope is not rude of me. It's not a book that I wrote, so I think it's okay. If I had done that, it would have been a lot worse. Also, I'm going to beg Giege's indulgence if I talk about only a very small amount of time in comparison to the amount of time that we've been reminded has existed here on the Earth. But I hope that you will see that there's a reason behind this very personal perspective and reaction to the theme. So I'm only concerned really with the last 3,000 years or so, and I'm really only concerned with about half of that period. And you could say that my main concern is even with just the beginning and the end of that period, which is just a few hundred years in each case, which is kind of an embarrassingly small amount of time in this company. I'm also concerned with a name, which may be embarrassing, because in each case, the brief stretches of time, which are no more than blinks of an eye when we compare them to the scale that Giege was talking about, that Graeme Barker was talking about, are known, or have been known, by the dubious name of the Dark Ages. And you don't hear much about the Dark Ages anymore. Nowadays, we talk about the Middle Ages, or the early Middle Ages, or late antiquity instead. But you did hear about them when I was a student. I know if I tried explaining this to my own students today, they would think that when I was their age, it probably was the Dark Ages. But it wasn't, even if you did hear about the Dark Ages more than you do today. The surprise to me was when I learned that there was more than one period that was called the Dark Ages. And I learned this at the same time, that both of these Dark Ages, on one theory anyway, could have been caused by the same thing. And that thing was none other than global warming. And this all happened when I was a junior in college and I was taking a Greek history course. The title of the course was Periclean Athens, but the professor was more interested in early Greek history, so we spent a lot of time on the period just before Pericles. And in fact, by the time the semester ended, and this sometimes happens, we had just reached the time of Xanthippus, who was Pericles' father. So we ended up with some understanding of the conditions that immediately preceded those of Periclean Athens, but not much understanding of Periclean Athens itself. And that turned out to be a very good thing, because the whole idea of a course in Periclean Athens depends on the notion that history is shaped mainly by great men. Now, sometimes that's a useful idea, but our professor obviously wanted to stress that great men don't just pop up out of nowhere, and that they can only do what their contemporaries, their predecessors, and their environment permits them to do. Well, anyway, the time eventually came for me to write a term paper. So to help me think of a topic, I decided to spend some time browsing in the library. And in the process, I found a book by Rhys Carpenter, who used to teach at Bryn Mawr, not far away, under the title Discontinuity in Greek Civilization, 1966. And this turned out to be just the book that I needed. But more than that, it turned out to be one of those books that actually changes your mind about something and does so permanently. I didn't know it would do that. In fact, when I picked up the book, I probably would have bet you that it wouldn't. Because to tell the truth, the main reason it appealed to me was that sitting there on a shelf full of weighty tomes, it was so small. It was only 80 pages long, and the pages weren't all that big either. Just 3 chapters. And even better, these turned out to be lectures that Carpenter had given at Cambridge University, so the style was suited to oral delivery, to an academic audience, but apparently a fairly broad one, and not just archaeologists and historians. This meant that it was practically devoid of technical terms, convoluted sentences, hedging, and so forth. It did not bristle with footnotes. All of this made it look very approachable to an undergraduate, just as a way to get started. I didn't think it would give me everything that I needed to write my term paper, and I certainly didn't think I would find myself talking to all of you about it some 35 years later. But the truth is, I found this book so fascinating that I sat right down on the floor in the stacks and read the whole thing straight through, probably in less time than it would have taken me to read 80 pages of a really good novel. And it did change the way I thought about things that were and still are very important to me. And here I am, 35 years later, telling you about it as well. So why was this book so captivating? One reason is that its purpose was simple. I've been warned by Professor Barker about simplicity, so I beg his indulgence as well. But there was a very appealing thing about the simplicity of this book. Carpenter wanted to explain a long-standing problem, and that is that there's a gap in the material record of Greek history that exists between about 1200 and 800 BC. Instead of enormous palaces and impressive fortifications and goods that travel throughout the Mediterranean, which are characteristics of the earlier period, for about 400 years we find much less or little or no evidence of monumental architecture or large-scale trade or material remains of any kind in comparison with the previous period. And this is what's called the Greek Dark Ages. In cultural terms, it marks the separation between the Mycenaean Greeks and what we call classical Greece. So just learning that this period existed was the first revelation that I had that day, that there had been another Dark Ages. Before that, Dark Ages was a term that I had only heard used to describe the period that followed the end of classical antiquity, starting in about the 6th century AD. But now I learned that there had been another Dark Ages that preceded the beginning of classical antiquity in about the 9th century BC. And this was a revelation because, as far as I knew, the narrative of Western history considered that the later Dark Ages was a kind of unfortunate and even anomalous interruption in a trajectory of progress that was resumed in the Renaissance and that continues unabated today. But instead, I had to realize Dark Ages were recurring phenomena. And that was interesting all by itself, and it had consequences. For instance, classical antiquity, the period I was mainly interested in, began to look very different to me when I started thinking of it as an interval of about 1400 years, bounded on both ends by periods called the Dark Ages. In fact, civilization as a whole started to look different to me. rather than a single upward trajectory of enlightenment that was inexplicably interrupted by a single period of dark ages that came out of nowhere, I began to think of multiple dark ages alternating with multiple periods of enlightenment. And I began to ask myself which was the norm, the recurring periods of enlightenment or the recurring periods of darkness. Now, so far, I think none of this is very controversial. I learned about the Greek Dark Ages from Rhys Carpenter, but I might have learned about them from any number of other sources. And Carpenter's book did send me to many of these other sources because the idea of the Greek Dark Ages was, and basically still is, a standard one among Mediterranean archaeologists, historians, prehistorians, and so forth. And the idea of a similarity between the Greek Dark Ages and the later Dark Ages is perfectly reasonable because both of these Dark Ages followed the collapse of a wealthy, highly developed, widely dispersed culture. Mycenaean Greeks on the one hand and Romans on the other. But what made these cultures fall? I discovered that there were lots of ideas about what caused the second Dark Ages, but not so many that I could uncover for the first. And so my second revelation came when Rhys Carpenter proposed the same cause for both, and it was a simple one: climate change. Now, Carpenter, it has to be said, loved to propose improbable solutions to insoluble problems. Sometimes his solutions were improbable because they involved a combination of factors, and not just one or two, but lots of them. Each one of these factors might be perfectly possible in and of itself, but his theories often required that all of them turn out in a very particular way with almost no margin for error. And if any of them didn't, then the whole theory collapsed. Of course, the likelihood that all of them happened exactly the way that he needed them to was almost infinitesimally small. But usually, these theories could neither be proved nor falsified, so that Carpenter's rhetorical skills, which were almost unsurpassed, often carried the day. But that is only one kind of improbable Carpenter solution. The other was improbable because it was paradigm shifting. It came right out of left field and bore no relationship to anything that anyone else was saying. And climate change was more in this category. No one, or very few people in classical studies in the 60s were prepared to believe that global warming put an end to the Roman Empire in the 6th century, or Mycenaean Greece 1400 years earlier. But Carpenter did back up his theory with science, and especially with dendrochronology, but also with other sorts of climatological evidence as well. And his evidence came from all over the globe, not just from the Mediterranean basin. He did not use the phrase global warming, but that was, of course, exactly what he meant. The whole Earth, he argued, suddenly got warmer during the first Dark Ages and the second. The Earth got warmer, and great civilizations fell. In this case, it was not just Carpenter's rhetorical seductiveness that made his theory attractive, it was the science behind it as well. Now that's about as far from the great man theory of history as you can possibly get, and you can see why I found Carpenter's ideas so powerful. In some sense, it didn't even matter if they were right, just the idea that history had to be viewed in such a different way was what was so exciting. From my course on Periclean Athens, which never actually made it to the time of Pericles, the main thing that I took away was that the most important events in history might have nothing to do with great men and everything to do with occasional and relatively minor fluctuations in planetary temperature. So, classical civilization, my main interest, became for me not only a relatively brief period, bookended by inexplicable dark ages, but one that was hedged in by catastrophic climate change. Or, looked at from another angle, it was a period during which a civilization managed to flourish relatively briefly between two even briefer periods of inevitable change that take place in the Earth's climate. And what's more, I was going to say, the inevitable and unpredictable changes that take place in the Earth's climate. But what if they were predictable? I couldn't help noticing that the period of 1400 years between Carpenter's Dark Ages, which defined the entire trajectory of classical civilization from its rise to its fall, was exactly the same span of time that had elapsed between the end of antiquity and the present day. In other words, if Carpenter's thesis was correct, and if in addition his Dark Ages were caused not just by changes in the Earth's climate, but by more or less regular and periodic changes in the Earth's climate, then we should be just about ready for the latest installment in a long-running series of disaster movies. Only the earlier installments weren't movies, but historically and experientially verifiable times in which civilization actually declined. Now, lo and behold, as if right on cue, the Earth is warming, ice is melting, oceans are rising, because fresh water is melting into them, making them less salty. And as this happens, the course of the Gulf Stream is being diverted, which will have an enormous impact on anyone who lives anywhere near the North Atlantic, especially in Europe. Bad news for Mrs. Merkel. Issuing Eurobonds and throwing bankrupt member states out of the EU won't be enough to solve this crisis. It's as though the Dark Ages that felled the first of the great Greek civilizations and then toppled their Roman successors were now coming after us. Now, of course, it's not that simple. The book that we are actually celebrating today on climate crises in human history teaches us that it is not that simple. We can make educated guesses about what the climate will do, and we can take measures at least not to do things that might make the situation worse, but we can't really predict what will happen to our civilization. As a humanist and a classicist, I have to say that I find this situation extremely fascinating, and not least because it looks as if it could change the way we think about our civilization and about ourselves. There are two ways in which I have always thought that the last 50 or 60 years resembled certain periods or conditions of antiquity, and both of these have to do with annihilation. During the Cold War, which defined certain conditions of my own life from as early as I can remember until well into adulthood, and it certainly marked the lives of everyone here, you just couldn't avoid thinking about the possibility that our society might one day be completely destroyed. I used to think about this, and I used to wonder whether this was another one of those supposedly unprecedented conditions within the human experience that collectively define what it means to be modern. Or if in fact the kind of existential anxiety that we associated with nuclear war had already existed in earlier ages. Analogies are always imperfect, and perhaps many people would find what I am about to say just unconvincing because of the different scales and technologies involved. But I decided, and I still believe, that the thoroughgoing destruction of an ancient city by an opposing army was a reasonably close ancient equivalent of the nuclear option. The mythical paradigm is that of Troy, the historical one is Carthage. Jerusalem as often offers a special case. Perhaps this kind of destruction was not mobilized very often, but when it was, entire populations were wiped out, together with their means of earning a livelihood, and all the political, social, and religious institutions that defined them as a people. For some time now, we have lived without much fear that our entire civilization would collapse in a nuclear war. When that possibility faded, the narrative arc of human history seemed to be confirmed. Reason had prevailed. The incomprehensible possibility that humankind might deliberately destroy itself in seeking to defend itself gave way before proof that we were really enlightened beings after all. The benighted among us may still use these weapons in pursuit of their benighted ends, but it seems unlikely that anyone will or would use them on such a scale as to represent a basic threat to our civilization. Reason has prevailed, and it will prevail. For students in particular, virtually all of whom nowadays were born after the Berlin Wall came down, the threat of nuclear holocaust has hardly any meaning. But it now appears that we face an even more basic threat. It may be that we bear no responsibility for creating this crisis, and that nothing that's within our power could possibly avert it. Many of the essays in the volume that we are celebrating show that adaptation in the face of such events is possible. Several also show that there are limits to civilization's ability to adapt to climate change. And whether or not you find my Cold War parallel convincing, when we are contemplating a future that does not simply continue the triumphal narrative of continuous progress that has defined our history for generations, especially in the West, but that contains a credible threat that our near future could be one of scrambling, coping, improvising, and eking in the face of planetary change that we are powerless to predict with total certainty, let alone to prevent. I would propose that we are like those people in late antiquity who saw signs that something was coming to an end. I think of Augustine writing about the sack of Rome in 410 in a way that suggests that he realized if that could happen, then anything could happen. But it's not just Augustine and people like him living at a particular moment who could see the end of antiquity approaching. In the thought world of the ancient Greeks and Romans, the beginning of time and the end of time were never very far away. Their concept of space was fairly large and in some ways not so different from ours. Hellenistic scientists succeeded in figuring out that the Earth is a sphere. Knowing this, they accurately measured the circumference of the Earth to within a few hundred meters. But they also realized that the size of the Earth, which they had accurately measured, was incredibly small compared to its distance from the vastly larger sphere in which they thought the stars and constellations were embedded, which they understood to be, in principle, infinitely far away. Realizing this, they were able to devise a simple way of calculating the latitude of any place where they happened to be on that sphere. So their conception of space was really pretty impressive, especially if you consider the very simple instruments that they had to work with. Basically not much more than sticks and tubes. But time was much more difficult to measure. The chronographers who ingeniously wove together the various accounts of historical and prehistorical time that had been kept by the Egyptians, the Assyrians, the Greeks, and eventually the Jews, never managed to account for more than about 60 generations of human experience. By conventional reckoning, a generation lasted only 30 years, and history, properly defined, occupied only the most recent half of this period, about 30 generations, or just 900 years. Before that came the heroic period, which would have lasted about the same amount of time, and before that was a period that they just called obscure, because it occurred before the creation of human beings and so lay beyond their ken. It is unclear how long they thought this period would have lasted, or whether they even thought that time had any meaning with regard to it. So by our reckoning, the Greeks and later the Romans thought of 900 BC or so as a dividing line between the age of heroes and their own historical age. It is not a coincidence that this date, 900 BC, falls squarely in the Greek Dark Ages. The Greek culture that emerged from this period regarded with awe the achievements of the Mycenaeans that were visible to them, like some of the abandoned palaces, and the legends that became the basis of poems like the Iliad and the Odyssey. No wonder they considered the period before the Dark Ages to be an age of heroes. But their distance in actual time from this heroic age was never very great. By the time Augustus came to power in Rome, the historical period had lasted as long as the Age of Heroes had. The world had come to seem old by that measure. The poet and philosopher Lucretius had already argued that the earth itself was in its old age. It must have seemed to some who thought about these things that the end might be very near. And by the time it did come, whenever we think that is, in the form of the second of Carpenter's Dark Ages, it must have seemed to many as if humanity had been living on borrowed time for a long time. Such were certainly the ideas of those who lived during Europe's long, slow recovery from the Dark Ages as the year 1000 approached, a number that to many suggested that time itself must really be coming to a close. The point here has to do with my professional interest and in a way with the reversal of what some people say is the purpose in studying history. We're supposed to study history so that we can apply the lessons of the past to the present and the future. Instead, I'm using the current predicament that we face to understand the past. What was it like to live in a civilization that was conscious of not being very old and that believed that it might not last very long? The insights of earth science and climatology prove conclusively that in terms of geological time, no civilization, not even civilization itself, has ever got to be very old. And so in a strange way, these insights have the power, it seems to me, to rescue us from a belief that the way things are is the norm, and that the future should always be like the present, except better. It may be better. If I can return briefly to Rhys Carpenter's idea, this time about the second Dark Ages, there is one very puzzling fact that it does not explain. Many facts that it doesn't explain, but there's one that I'd like to focus on. As Carpenter shows, the decline of the Roman Empire and the beginning of a fairly long-term period of cultural recession throughout Europe in the early Middle Ages seems to be correlated with a rise in planetary temperature. But this same period witnessed the astonishingly rapid rise of a new world power in the form of the Islamic Empire. Curiously, this new empire not only arose at the same time when global warming, according to Carpenter, was causing European civilization to collapse, But it also arose in a part of the world that was vastly hotter than Europe all year round, and that was not far from the vast wasteland of the Sahara that was once hospitable to human life, but became totally inhospitable as a result of repeated climate events more or less like the one we're discussing. In other words, the kind of global warming that brought about the European Dark Ages, if it did so, and made the Sahara a desert, did not prevent the astonishingly rapid rise of Islamic civilization. During this period, and for centuries afterward, all the largest cities in the Mediterranean world were in the south and east, where conditions were warmest and driest. Meanwhile, cities like Rome, that had once housed about 1 million inhabitants, or London, that would eventually hold that many and more, supported as few as 30,000. So I can think of 3 possible explanations for all of this. 1, Carpenter is simply wrong, and climate change had nothing to do with bringing on the European Dark Ages or with the rise of Islam. 2, Carpenter is right that the European Dark Ages were caused by global warming, but that in the meantime, Islamic culture arose in spite of global warming under even more trying climatic conditions. 3, Carpenter does not really answer anything, but forces us to ask a big question. Because it seems that global warming did occur at the end of antiquity and the beginning of the Middle Ages, but a mechanistically climatological explanation of great shifts in the history of civilization may simply be too reductive, probably is simply too reductive. Carpenter implicitly assumes that the Greco-Roman civilization declined because it failed to adapt to climate change. Possible. But he does not consider the possibility that Islamic civilization thrived because it adapted well to the very same changes, perhaps in an even more intense form. The possibilities involved in this idea are too many and too complex to explore today, and in any case, I'm not the person to lead that exploration. I would leave that to others, but in closing, I will mention just one possibility, which I think has to bear on our situation today. The Roman Empire at its height was an entity that was heavily invested in infrastructure, much of it not very productive. Think of the baths of Caracalla, and think of the expense involved in simply maintaining such a facility. Islam arose in a nomadic setting, and even if it quickly developed a highly urbanized culture, complete with prestige architecture, impressive religious institutions, famous universities, and so forth, perhaps it was an advantage not to have such things and not to have to maintain such things at a time when the rise of this civilization began. And perhaps there is a lesson in this as we consider the current condition of developed and developing nations in our world, which seem to be locked in a rather intricate and somewhat uneven game of chess as they try to compete to maintain or improve their condition vis-a-vis one another against a background of rising planetary temperature. Thank you.
I'm going to ask Guy and Graeme to join me here on the stage. There should be some chairs here. Or did you have your toilet paper model already to hand? And history has turned out to be the way you would have predicted.
Well, no, I mean, there were other perspectives that we solicited and did not get. And then some of the people who came forward with these articles often is very interesting stuff. As I said, you can't tell people like this what they ought to write about. But one perspective that I hope to get, and I don't even know who we would have asked to do this, was somebody who could talk about the role of changing climates in the last several million years that led human species to change from a poly-specific form to the single human species we have today. And people have speculated that that's a consequence of accelerated selection pressures which were driven by changing climate. So one story you can take from that is that we are here, who we are, as a direct consequence of very great difficulties our ancestors passed through in the last 4 million years. And it got rid of all those extraneous homo habilis, and all those other also. But we couldn't find a person who would represent that perspective. And the other person I really hoped to get, but he was unable to join us, was Bill Rutherford, who wrote the book 2005, Clouds, Plagues, and Petroleum. And he found in the Antarctic ice core direct chemical evidence of the discovery of agriculture, 7,000 BC, 7,000 BP, the development of agriculture across Europe 5,000 years ago. He also saw evidence in the ice cores of the two European plagues and of a wholesale depopulation of the Americas in the 16th century. So he was able to show that populations much, much smaller, orders of magnitude smaller than the present population, were able to alter the chemistry of the atmosphere far, far long ago in the past, which is an interesting perspective to offer to those who continue to insist that even 7 billion people can't have a significant impact on the climate. So yeah, I didn't get exactly what we expected, but we got better than we expected in some respects. And what the volume lacks is any kind of a consistent repetition of the theme. So, like any good undergraduate major, we leave up to the consumer the responsibilities of making all the different arguments.
Thank you, Keith. Now I'm going to be very naughty and talk and invite a colleague who's in the front row and typing away at the present time, because Michael McCormick, Professor of Medieval History at Harvard, took part in the discussion, and although he's a medievalist, and a very distinguished medievalist who's worked and created quite a stir actually in the debate, if you recall, because of his work on volcanoes in the post-Roman period. He's just worked on, he informed me, he's here for the APS, he's just completed and submitted a big essay on the state of the climate in the Roman period. And I wondered, Michael, as someone who specializes in Dark Ages, I know it's very unfair to call on you, whether you subscribe to Rhys Carpenter's view and what you might make of the Roman period too. It's very unfair to ask you, but I know you won't be put off by answering me.
Among old friends, sure. What Richard is referring to is an article that I had the pleasure of being the lead author of, that is the product of a collaboration of a dozen climate scientists, historians, and archaeologists, which reviewed the evidence from about a dozen different, what the scientists call proxy data sources about climate. Ice cores from Greenland, tree rings from Europe, the speleothems with the oxygen isotope ratios, etc., solar radiation, and other such things. And what we tried to do was to draw kind of a white paper of the state, what is known from science, history, and archaeology about the state of the climate under the Roman Empire. I'll jump right to the punchline. Global cooling? Possibly. It would be most fair to say that what we were able to do is to document in great detail our ignorance. We have many, many dozens of points of ignorance. We have a few dozen points of light across the entire space of the Roman world. What we set out to do was to draw the balance sheet of what we know, what we need to know, where we need to go next. And what we were able to do was to draw a kind of a big picture from 100 BC to about 800 AD. And in that, one of the key things that we see that is extremely striking, that has been suspected before, but that I think we were able to document from multiple independent indicators, is a period of extraordinary climate stability between about 100 BC and about 150, 200 AD. Between about 150 and 200 AD, we start to see an acceleration of variation or fluctuation. Part of it appears to be volcanic in origin. The 3rd century, along with probably the 5th and possibly the 6th, there are some problems with the ice core records in the 5th and 6th centuries, has the most extreme volcanic activity. This refers to a mechanism that the members of the APS here present will be pleased to hear. The first person to claim it for science was a certain Benjamin Franklin. The effect of volcanoes on solar radiation, very, very powerful volcanic eruptions, are now known to block solar radiation and therefore cause very rapid and short-term cooling of the atmosphere. This played a role in the 3rd century and possibly in the 5th and 6th century, but between 100 BC and approximately 150 to 280, remarkable climate stability across, certainly in the western area of the Roman Empire, possibly in the eastern area, with certainly more favorable humidity in humid conditions in the Levant. Change in stability starting about between 150 and 200. Recovery in around 300 in the west. At some point between 300 and 400 in the east, the dating of Dead Sea water levels are based on archaeological evidence, which can be contested, that our Hirschfeld worked out, and on radiocarbon dating, which unfortunately the 2 different series of data have 2 different radiocarbon dates. So the good time for the Levant started either around 300 or around 400 or somewhere in between. That's good enough for a lot of geologists, not sure for us. And then more big trouble in the 6th century. So that's kind of the long and short of it. We need a lot of more evidence. We would like evidence, particularly from the Levant. There are good scientists there, and there are good deposits of data, but people have not been interested in looking into the this very late Holocene, when we had the opportunity to go to this very difficult problem that Graeme Barker underscored, and that is, first of all, observing correlation because of chronological proximity, and secondly, causation, where you really have to know whether something happens before or after what it is thought to have caused. And for the last 2,000 years, last 2,500 years, we do have written records that are good enough to allow us to do that. And I think that the scientific proxy data, particularly the ice cores trees, and perhaps the speedy events, will allow us to go there too. So,
Thank you very much, Michael. Fantastic. Now we have half an hour. I wonder if, are there any, well, there must be some questions of my distinguished panelists, and if not, we will have to take away your toilet roll and do something else with it. Please, the lady in the front row, second row.
Should I stand up?
Well, just stand up and
Shout out.
In terms, I'm a recovering anthropology major from the 60s. Everything was wrong. One question I have is why is there no information about the Western Hemisphere? No emphasis on the Western Hemisphere because there's not area specialization. But I'm more interested in being a recovering anthropologist. More recently, more interested in demography, populations, and population health. And there's a big, in terms of looking to the past for changes in social control and how populations adapted to changes in the climate. I think there's a big disconnect between then and now because population sizes are so much greater now. There's never been more people living on coasts. There's never been more people, even in, not so much in the interior, but past the coast. And the inevitability of breakdown is so much greater now. And I don't think, I wonder what kind of lessons can be taken from the way people are.
ask you and Graeme to comment on the demographic issues.
Well, we did not deliberately exclude the New World. We had participants who talked about archaeology in the Americas. And it might be a cultural thing, but they didn't send us any manuscripts.
There is a line paper.
Yeah, there wasn't a Western US of A paper.
And there's a megaform paper as well. There are 2 papers.
Yeah. The detailed chronology of the American High Plains, for example, was something I was hoping to find in there, and the duration of the climatic optimum. But we didn't get that. We could have continued to recruit people and continued to recruit manuscripts, and this book might have been many more years in the making, and then the people who originally sent us their manuscripts would have been very unhappy with it. So the time came when we wrung the chicken's neck and sent this thing to press.
Well, there were periods of dark and
There were, yes, what?
There were periods of dark ages, the same kind of pattern of dark ages and unexplained periods. Personally, I think we should go back and reread Velikovsky, wonderfully planned.
Graeme, do you have any thoughts on that? You've done a lot with demographics.
No, it is the most difficult aspect of all archaeology to put numbers on periods, particularly get into the remote past. And you know, I completely take that argument. People will say, well, it was all so different then, the numbers are so small in different periods. You know, to what extent is this relevant? And actually is like a truth in terms of the scale of it, actually both people's capacity both to destroy things and the technologies to try to figure it. But clearly it's beyond anything in the past. So I agree with you, but that doesn't mean that one can dump the past. And I suppose what particularly affects me is often in the sense that people do use the past to their own ends. They do use it in general. They do take a sort of simplistic lesson. And I think one has to say that yes, the numbers are different, but the humans, at least from 200,000 years ago, the problems have been much like us. So at least one can try to use that past record for what did humans perceive and for right there. So I agree with you, but I think the trouble is people do so use the past, whether political ends or just simple good stories. We do have to try to get what we can out of it. One of the more interesting things at the moment is the whole role of technology. In this coldest period that we talked about last year, about 25 years ago, we know that populations concentrated in parts of Europe, southwest France, the Pyrenees. There were 2 or 3 refugia. In fact, where we're working in the Half-Tower Cave might be another refugia. What's interesting is that at one point, the radiocarbon data suggested that then as the climate ameliorated in our term, warmer, wetter, human populations expanded out over the whole of Europe. Actually, what we're now clear is the human populations expand out while it's still, in our terms, appalling. It's still very, very cold and dry. And yet somehow there are technologies that enable people to expand out. So actually, the human species seems to colonize Europe. The technological and cognitive things that came together, if you like, despite what you might expect from climate. So I start with you where we are and say that the hardest thing is it is such a different scale because of the population. Nevertheless, we can get at useful things about human perceptions and human decision making and so on and so forth.
It may be immensely interesting to examine ourselves, but in this whole conversation there hasn't been one mention between dark and light and heat and cold of the sun.
No, I'm sorry. Claudio has been studying the sun for a long time, and he's the man to answer that question. Did you hear the question?
Can I mention 2 things before that, which arose from the discussion? One is recently the volcanologists, international volcanologists and international seismologists said that when we speak to the public, we must have a single message. If we're disagreeing among ourselves, they won't trust us. It seems to me that's entirely wrong, that you won't trust us if we all sing from the same hymn sheet. Yes. You must see that there is this agreement. And there is, unfortunately, the climate change.
Finzi 2008, The Sun, a User's Manual, published in New York by Springer. I recommend this to anybody who's really interested in what we know now about the role of the sun in this process.
Fantastic, Claudio. Thank you.
Just to say, to answer that very briefly, coming back to this, trying to work out how there are subtle differences in the sense that the big scale is known like that, as Claudio says, how that actually translates into weather, into climate, into temperature. For human populations at the scale we experience is something that is ongoing now. So this 20,000 period, it's becoming clear from work that the humans who were in Morocco and that northwest Africa, the humans who are where we are in Libya, the humans who are in the southern Levant, the northern Levant, Greece, it actually played out in different sorts of ways, because you've got, as you said, you've got kind of weather changes, the north-south, you've got the Antarctic Arctic changing, the Atlantic westerlies, there's the monsoon, the Indian monsoon, all of these are fluctuating. So that's why I say I think the big agenda for archaeology is that we need these long-term, high-quality climatic records, proxy records. I wasn't discussing those, but they're absolutely vital. And somehow we have to reach from those to bridge across to these human stories and the collections of environmental data we can actually put specifically around in the world that humans lived, and then try to put those together.
Can I, before I take another question, can I ask a question, Claudio? It's very unfair, I know, because I've tried to persuade Claudio to join us on the stage, but in the 40, 50 years you've been studying these, you've been looking at climate and the environment. How do you think archaeologists have fared? How has it changed in your mind, the way archaeologists have approached the past? And do you think we're getting closer to understanding man's involvement with the environment, climatically speaking, as Graeme was describing it? You have a long view of it. I wondered what your view was.
My view of archaeology?
Yeah.
You passed my PhD thesis.
My limited impression of archaeologists is that they don't care about these things. They're interested in parks and jewels, swords, kings and wars. If you see recent exhibitions of Greek treasures that have been found, the entire narrative is to do with battles and kings and successions, and whether that scar was done by a sword or an axe. The climatic influence that, as we've seen, is profound, if indirect and often mysterious, tends to be ignored by most archaeologists, I'm afraid.
I deserve that. Please.
Following up on the question about the sun and the word that the man for authority on the sun used was that the sun works in a devious way. Now, I think that to pay attention to the meaning of words, thus to sometimes invite a philosopher to whom the meaning of a word is life itself. There are two words here. One is change, the notion of change, and the cause of it. That it is possible that the cause of change is the notion of change itself. And what does not change is the changing of change. That's one notion. The second one I want to ask your authority, because the question about the sun is a very important one. There's a very big difference between speculating about the sun. We are just beginning to understand the phenomenon of a candlelight. Just what is happening in the light of a candle. So for us to really understand the difference between sophisticated speculation, which is high entertainment, and truth-telling, which is reporting on the truth, which is education, which is educare, to bring into the world of truth. And I am simply asking you to try to make distinctions in a dark age, in a perfect storm, where navigation is the most crucial, and without a compass of the truth, it does capsize, which is just fine.
Claudio, do you want to respond to that, or shall I ask Joe? Yes, Joe, and you deal a lot with navigation, so.
Thank you. I think that one of the points that I took away from the book is much like what you said about the impermanence and inevitability of change. And the efforts, that the contributors to the book have made simply to chart change and make the point that it doesn't make sense to assume that the Earth ever existed in a steady state, except perhaps for very short periods, but that the Earth doesn't normally exist in a steady state, that change is the norm, that adaptability is the thing that has really enabled every species that's alive to succeed. I think that these are key points, key general points that come out from the book. So in that sense, I think your comment is very much the point.
And we can say with some confidence, because of the size of the present human population and its invasion into all kinds of environments which humans avoided at times in the past, that people are becoming more vulnerable to climate changes which previously we would have considered normal. So I think we can say there has never been a time in the history of Earth when 7 billion people would not have been at risk from the consequences of climate change, whether warming or cooling. The problem today is the population pressure, the extraction of resources, and the disposal of waste, because the climate change has been with us continuously.
Is there evidence that climate change is correlated with human disease of any kind, particularly infectious disease, correlated in time with, say, the Black Death period in Europe?
Can I ask you, Michael, to comment on that?
Sure.
Michael's worked a great deal on the bubonic plague. He published a great many important articles.
If I answer, will I get invited to dinner?
You will.
Sing for my supper. Yet, in fact, there's very interesting evidence with respect to the Black Death, the bubonic plague that hit the world, really, in the late Middle Ages, is a disease of rodents, principally the black rat. And the connection with, there actually is a group of European dendroecologists who are exploring these connections, even as we speak, and have threatened to drop the paper on me too. So I may have more detailed information about that. But the real link that they may or may not know about is that studies of insect and general life populations, organisms in the American Southwest are correlated with precipitation. And when you get a jump in precipitation, you get a trophic cascade, which produces all kinds of organisms, which produces, in the end, much more food for our local vectors of bubonic plague, as to say prairie dogs. Cute little prairie dogs have plague, remember that. There is therefore, very good reason to explore the precipitation record around the northern hemisphere for the two periods in which we suspect that there were global pandemics of plague, the 6th century AD and the 14th century AD, and of course the 19th century AD too, because in that trophic cascade that's correlated with precipitation, we may well expect to find causes for a gigantic explosion of the rodent population, which brings the vectors of plague into the forefront of human civilization, and of course produces stress in the population also, which might make it amenable to the plague, susceptible.
Does that answer your question?
Yes, sir.
It's the beginning of the
A
answer.
question that follows, I guess, is it, if one is thinking about advances in civilization, is it more or less favorable to have a larger population?
Yes and no.
You can tell he was an editor.
But archaeologically, there are so many instances where, if you like, there is a cultural change and a demographic, or rather population in this period, the population actually is bigger, but you either get into this Malthus idea, or the alternative is the Boser idea, that you've got population pressure, forced intensification, and I can't think of any example of deeper periods of prehistory where anybody has been able to separate the sort of chicken and egg in a convincing way. I've written quite a lot taking the kind of Boser view, but I can equally see now one could actually turn it completely round. So I think there are many, for example, a lot of discussions about early agriculture, urbanisation, and round about whether population pressure was a factor, and equally other people argue that changes took place for other reasons and population rose. And as I say, I think I can't think of any of those instances where people showed in also in a way that excluded other factors. It's always with this with equifinality, when people take this and that and say that affects that. That's hard enough. But what about all the other things you're considering? So I can't think of any instances really now we can really point to a clear causal relationship in the deeper prehistoric period. For all that's said about, and the change to agriculture is the most obvious one. Major changes it looks like in population, but the debate goes on and on and on about the extent to which one followed the other, or the other way around.
One last question. Yes.
No, I don't deserve to be the last. Someone's got to really. When you looked at the ice cores, you looked at places where there weren't populations and there wasn't stuff. It just happens to be a place where you can get at stuff that hasn't been disturbed for quite a while. Most of the sites that you're talking about or something like that. Does anyone look at, say, Mount Everest, the very high places? Are there cores taken from there?
I don't know if there's cores from Mount Everest, but Lonnie Thompson from Ohio State has cores from the length of the Andes. There are ice cores from the tropics, there are ice cores from the subtropics. And the basic climatic oscillation is preserved in all of them. There's local variability, but we know that the composition of the atmosphere mixes in about 18 months. We know that from the distribution of bomb, radiocarbon, among other things. So it's reasonable to assume that the precipitation that falls on the Antarctic ice sheet has access to a similar chemistry of atmosphere as that falls on Greenland or that falls on Peru. And the empiric data from the tropical and subtropical ice cores support that. It's different because the rate of accumulation is very much higher. And it's possible to see in the Andean ice cores individual dust layers that represent annual layers. So in fact, the chronology is much more precise. But the duration of the Andean ice cores is much shorter. What fascinates me, and I haven't, in the 1990s, a group from the University of Maine discovered glacier ice in the Antarctic underneath a volcanic ash that dated 14 million years. And so there's a preserved hunk of glacier ice down there, which will tell us something about the history of climate in Miocene time and the composition of the atmosphere. They've had very great difficulties in getting a decent core through it. And there's a lot of concern that the core might have been contaminated over the 14 million years that it sat there. But there are ice cores from other sites besides the polar caps.
And in the example I gave of the Southeast Asia, the climate story is being reconstructed from cores on the ocean sediments, but also, for example, the cave where we're working at the entrance, it's very well known because it has a huge population of bats and birds, and the swifts are ones that they make Chinese birds nest soup out of, and a huge population of bats. The bats therefore create guano, and therefore the idea of climate changing outside, therefore vegetation changing outside, therefore the bats taking the fruit or the insects, and therefore their guano at various proxy stages being a continuous record of climate change. And there's a lot of work now going on. The Nia Cave, the Lulu Cave, a lot of these tropical caves, where people are beginning to get long-term continuous deep, and not like that. This is 200,000 years, but for humans, sorry, that will do nicely because our species goes there about 50,000. So there are these records coming out now, studies of the chemistry of bat guano to fit these deep sea cores.
And there's another, we have recently proposed, but I think not likely to persuade the funding agency, that the very thick column of penguin droppings at rookery sites in the Antarctic preserves a very, very detailed record of the productivity of the Southern Ocean. Now, the 2 seasons I spent in the Antarctic, if we were sitting in McMurdo Base when we came back to base, and in the dining hall where everybody went to have their meals, when the group from the penguin rookeries came into town, the dining hall emptied out. So I'm not looking forward to pursuing this project.
In terms of global impacts, the stuff I showed, that Jordanian Roman mining, when it was also polluted, there are spikes in the Greenland cores, which are caused by the pollution thrown up by the Roman Empire, possibly also the Han Empire, the Chinese. In terms of the scale of metallurgy, actually, the amount of pollutants going to the atmosphere are being recorded in the Greenland ice core.
Well, could I ask Bruce to say a word?
I'm compelled to bring up a subject which I don't think has been discussed thoroughly. Old fan of Benjamin Franklin, the fact that he discovered electricity with his lightning experiments. I'll bring up points. 1859, there was a coronal mass ejection from the sun, known as the Carrington event. And the sun eruption happened to be pointed pretty much directly at the Earth. And this was observed by an astronomer in England named Lord Carrington, hence the name. At the time, that evening, when he observed this, there was an aurora borealis which was visible south of the Tropic of Cancer and north of Capricorn, where this was recorded. And in a conversation I had with one of our colleagues, Charlie Kendall, he's the head of the Scripps. He said, if we had a Carrington event today, it would destroy the power grid because our electrical equipment is not organized to cut off, to preserve that. Now, in 1859, all we had was a few telegraph wires strung around the Washington area, a nascent telegraph system. The Carrington event melted some of these wires and caused fires in the stations and shocked some of the telegraph operators. Nobody was killed, but if it would happen today, we would lose the power grid over Charlie for 3 to 5 years. My last comment on that is that Peggy and I went to a conference in Annapolis just a month ago. And I was appalled to learn that at Annapolis they no longer teach celestial navigation. And that was my field. I was trained to do World War II. Unfortunately, I never had to use it. Nevertheless, can you envision all the ships at sea depending on the GPS system, and all of a sudden, voila!
I'm going to ask Guy to answer this because this brings us to Joe's point about further Dark Age.
In the interest of total disclosure, I will tell you that a year ago, I conducted a study for the Department of Homeland Security about the Carrington event.
Really?
Yes. About its where?
I said,
sorry.
wow.
I got the information from the internet, I delivered it to the Department of Homeland Security, and they classified it. We undertook to reconstruct from historical accounts whether or not there had been previous events like that, because at the time of the Carrington event, the only evidence that something like that had taken place was the auroras and the failure of the very primitive electrical system that was then in place. But if it happened again, of course, it would knock out the GPS system, it would knock out the cell phone system, it would knock out most of our apparatus whereby we communicate effectively around the world. And the recommendation that this group I worked with offered to the Department of Homeland Security, we are not in a position to be able to predict when and if there would be a repetition of a Carrington event. And the only strategy available to those who are concerned about the future security of the United States is to, or any place else, is to build into the system resistance to the kind of currents that resulted from that. And it turns out that our GPS system, our cell phone system, all of this advanced electronics have all been manufactured by companies who tried to get the lowest bid. And of course, none of these systems is hardened to withstand the impact of another solar mass ejection. So what we hope may in fact emerge from this is that subsequent military contracts issued to prospective civilian producers will include a very substantial component of hardening of the systems to protect them. But we are a long way from achieving that, and if we have another Carrington event within the next 20 or 25 years, Bruce, it's game over.
A real dark age, Bruce. I think at this point I ought to invite you all to join the editors, Bruce Mainwaring, Claudio Vita Finzi, and Gieg, in Lower Egypt, if I remember correctly, for a glass of wine. I'd like to thank Michael McCormick for joining us. He can certainly join us for dinner, because he's sung for his supper about the plague. What more do we need to know about over dinner than a dead rat? And I'd like to thank Graeme Barker and Joe Farrell as well for offering wonderful critiques of this great book. So thank you all for coming and being